All right, continuing on, we have the graph of y equal x to the 1/3 power, which looks like this. We have x equal 8. Remember, I want to make sure you know what x equal 8 looks like. It's the vertical line, and then y equals 0. So the area contained is the area here. So to find that area, we're going to build rectangles like this. And so the bottom of the rectangle touches the x-axis. So this just gives us the height of the rectangle is just up to the function of x to the 1/3. dx is the thickness of the rectangle, and then I'm going to build the rectangles between 0 and 8. X equals 0 to x equal 8. And that would be it. Alright, so this looks similar, doesn't it? But y equal 8 instead of x equal 8. So here is y equal 8. And then x to the 1/3 looks the same. I'm just going to have it kind of grow up further. And then x equals 0. So x equals 0 is the y-axis. So now you see the area bounded is up here. Very different area. All right, so if I'm building a rectangle, this rectangle does not touch the x-axis. So that means I'm going to have a top and a bottom of the rectangle that I'm going to have to identify. Top minus bottom to find the height of the rectangle. So that's B for bottom. Okay, so the area will be, so the height of the rectangle times the thickness of the rectangle, and we can see the thickness is dx. dx wide is the thickness of the rectangle. Okay, so top of the rectangle goes up to the function y equal 8. Subtract off the bottom of the rectangle, which is x to the 1/3. And then where am I building the rectangles from and to? I can see I'm starting at x equals 0. And you know these have to be x values because it's dx integration. And then we're going up to where this is happening, correct? So I need to find out what that x value is. That gives me the y, where the function gives me a y value of 8. So it's like setting x to the 1/3 equal to 8. And then I'm going to cube up both sides. So it's going to be 8 cubed. I'm just not even going to figure out what that number is. It's a large number. So there we go. So that's the area bounded. So make sure you're comparing and contrasting and thinking about where the area is. All right, so this is using the graph of secant, which is, you know, the cups, and this goes off the cosine. So these asymptotes of negative pi over 2 and pi over 2 come into play because that's where cosine is undefined. So secant is the cup. They start here at 1. So that's a graph of secant between these two intervals. And then I'm looking for the y equal 2, which looks like this. So there's y equal 2. So I want to find this area here that's bounded. All right, so if I draw my rectangle, you can see the top of my rectangle and the bottom of my rectangle. So I have the top of the rectangle, which is 2, subtracting off the bottom of the rectangle, which is secant of x, dx, the width of the rectangle, right? dx thickness, that's where I'm getting the dx from. All right, so now I need to find out where to start building rectangles and where to end building rectangles. So it's these two x values. It is not pi over 2 and negative pi over 2, because those are asymptotes, right? So I need to find out these two places, these x values, where secant of x is equal to 2. So I know secant is 1 over cosine. So if I cross multiply, I get cosine of x is 1/2. So thinking about that, what angle is it that gives me cosine 1/2? That gives me the angle of pi over 3, if I'm thinking about the first quadrant. So what I'm going to think about is I'm going to go pi over 3, and then I'm going to go negative pi over 3 to get over here on the other side of the y-axis. All right, here we go. Find the area bounded by e to the 2x. So you know that's the basic e graph. Looks like this. Y equal x. Wait a minute, those are not intersecting, are they? No, they're not. So x equal 1 and x equal 3 vertical lines, right? So there's x equal 1, there's x equal 3. So this is the area. Be careful you're not using the x or y axis. It's the area bounded by all of the graphs. So again, draw your rectangle so you can see top of the rectangle, bottom of the rectangle. So my area will be the top function, e to the 2x, minus the bottom function, x. That's the height of the rectangle. Width of the rectangle is dx, thickness. And I'm building rectangles from x equal 1 to x equal 3. All right, let's just finish off these last two. So y equal 1 over x looks like this. And y equal x. All right, and x equals, so I've got this graph and this graph. So now let's try and get x equal 4. So x equal 4 is a vertical line. Let me change colors here. So x equal 4 gives me this line, x equal 4. Okay, so I need to find the area that is bounded. So this is, I'm going to put a big star by here. Be careful to look for the area that's bounded by this, this, and this. I see this is the area bounded. The x or y axis is not involved. We need to make sure we're thinking about that. So the rectangle is here. From top of the rectangle, bottom of the rectangle. So my area will be the top function, which is x, subtract the bottom function, which is 1 over x. Thickness of the rectangle is dx. So then I need to figure out where to build the rectangles from and to. So I'm going to start here at 1, because that's where 1 over x, y equal 1 over x, and y equal x will intersect at x equal 1. So you can use common sense, think about that, or try to solve it however you need. Okay, let's stop there and we'll continue with this next one next time.